Okay, we've got a vectors question. For the first thing, we've got to find the vector AB. So I've got point A, I've got point B, and there's a standard method for finding the position vector between 2 points, which is in your notes. It involves a subtraction. So you're going to be doing something minus something, say what you're doing, quote the formula, something minus something equals the answer, and that's your vector AB for 2 marks. Then in part 2, the keyword here is parallel. So how do we find that vectors are parallel? Well, vectors are parallel when one is a scalar multiple of the other. So you need to get your vector in a vector in the direction of the line AB. And then for L2, for L1, here's the equation of the line L1. For parallel, I'm just interested in its direction. So I need to set up 2 column vectors, okay, that are the directions. And then I need to argue that these 2 vectors are parallel, so I need a convincing reason to think that one of these vectors is parallel to the other. Okay? And then finally, I've got a verify. Verify just means check. Okay, so I've got the equation of L1. I've got the point D, and so to show that a point is on a line, a point being on a line just means that this equation here, R, remember, is x, y, z, so R is effectively coordinates. Okay, we need to show that this recipe can generate the coordinates of D. So therefore, we just need to find and check it works a particular value of lambda. So your solution to C is going to look like, you may have to do some work to detect this, but when lambda equals some value that you've found, okay, check what the equation generates, and if it generates the coordinates of D, then you are done. And don't forget, you need to comment. So at the end of it, you're going to draw the conclusion. So you're going to say, therefore, whatever you were invited to verify, this is going to be your statement at the end.